So this is your last video for Algebra 2. This is video number 36. And this is Chapter 6, Section 8. And this is all about imaginary and complex numbers. Okay, so a couple of definitions. An imaginary number. By definition, it's the letter I, and it is equal to the root of -1. We don't have a way for you guys to actually take the root of a negative number. So by example, I mean, if you have the root of -36, and if you punch that into a calculator, you're going to get an error. It's not going to give you any kind of answer at all. So what we can do is break this up into the number times the root of -1. And the root, then that's coming from here. Let me just highlight. So if you have a negative, that means it's -1 times whatever values under there, right? -1 times 36 is -36. So just break it up into the number that's under the radical and then a -1. And then you're going to reduce the radical like you always have. The root of 36 is 6. And by definition, the root of -1 is I. And you multiply these together and you get 6I. And this is a little cursive I, lowercase I, cursive lowercase I. I guess that should be in there. Cursive lowercase I. So I would not just make it like that. Because that could look like a 1 with a dot over the top of it. Make sure you put this little tail on there, or in text sometimes it's italicized and looks like that. But one of these when you write your I's, okay? So an imaginary number is literally just the value I, which equals the root of -1, okay? A complex number is the combination of a real number and an imaginary number written in the form A plus BI, where A is the real part and the BI is the imaginary part. Okay, so your real number, if you have something that's got a real number and an imaginary number, like 3 plus 6I, the 3 should always come first, the real part first, and then the imaginary part. Okay, so an imaginary number is quite literally just the I's by themselves, and you need to know how to deal with that. And then the complex number is a combination of both of those. All right, so I kind of mentioned up here, back up here, if you have a negative under a root, how you can deal with that. So that's if that's a perfect square. Let's take a look at a couple other things that could happen. Excuse me. You could have the root of a negative number that isn't a perfect square. Well, let's do what I suggested. Start with the root of the number and then the root of the -1. We know that this is I, right? So all you have to do now is break down the 20. So we have, this would be a 2 rad 5. And if you have an I in there, that gets stuck in between the coefficient and the radical. So the I goes between the coefficient and the radical when you write your answer. Okay, so this will look like 2i radical 5. That's how that will look. All right. And there's a couple that they throw at you. You know, if there's a coefficient out in front, you would just keep the coefficient. This would then become a 4, right? I mean, it will treat it exactly like all the other stuff that you did. All right. So now let's talk about, we need to talk about adding and subtracting imaginary numbers, multiplying them, dividing them. So if we are adding and subtracting, and let's put complex numbers because often these are the combination of the two. If you have something like, oh, let's go 3 plus 4i minus 2 minus 7i plus 6 minus 4i. Well, first, this is going to be just combining like terms, right? That's all you're going to do. And you're going to treat these just like variables. Treat just like variable expressions. So by that, I mean, if these were x's, you would just drop your parens if you don't have anything to multiply by in the front, right? And any coefficient. Here you have a -1, so I'd go -2 plus 7i. This is just a +1, so +6 minus 4i. And then combine like terms. 3 minus 2 is 1, plus 6 is 7. So I have 7. And then I have 4i plus 7i is 11i, minus 4i goes back to 7i. And this is in the form a plus bi. And this is your answer. Okay, that's straightforward enough. I'm pretty sure you can go and do that. When we multiply, here's a couple things you need to know about multiplying imaginary numbers so that you can multiply complex numbers. Okay, so we know that by definition, I is equal to the root of -1, right? So then I squared equals the root of -1 times the root of -1. So, well, let me even go backwards from that. Oops, I did so I squared is I times I, right? And we know that by definition, I is the root of -1. That's this one. And then this one is another root of -1. Well, what's the root of a number times the root of a number, right? If I have the root of 5 times the root of 5, we know that that's just 5. The root of 17 times the root of 17 is just 17. So the root of the root of -1 times the root of -1 is just -1. So I squared actually equals -1. All right, let's go to I cubed. I cubed is I times I, you could do times another I, but I'm going to do I times I squared, right? Well, we know I is just an I. And I squared, we just said, is -1. And so this is -I. So if you see an I cubed, that equals -I. And then if we do I to the 4th, well, that's equal to I squared times I squared. I squared is -1, so this is -1 times -1, and -1 times -1 is 1. And so I to the 4th equals 1. So you're going to only have these boxed in values in an answer. You can leave an I. This is okay to leave in an answer. But these are not. These ones cannot be left in an answer. Oh, Lord, I spelled that wrong. Let's just do this. Leave in an answer. So if you have a power or an exponent on an I, be sure to simplify to its equivalent. And that would be one of these values. Okay, so if you see an I squared in a problem, you're going to replace that I squared with a -1. If you see an I cubed in a problem, you're going to replace that with a -I. And if you see an I to the 4th in a problem, you're going to replace that with a 1. We don't really need to go any further. I to the 5th, I to the 6th, I to the 7th. Generally, you're not going to see anything bigger than an I to the 4th. And there's ways that we can handle those that we'll talk about next year in Algebra 3. All right, so how are we going to utilize that information? Well, that happens when you multiply and divide complex numbers. So now, if we multiply complex numbers, remember a complex number is in the form a plus bi. So here is a problem. You may see something that says multiply 4 minus 2i times 4 plus 3i. Well, you're just going to FOIL this out. And you're pretty good at that by now, so we'll just go and do this. We get 16 plus 12i minus 8i minus 6i squared. Well, there's a couple things that we have to do. We're going to simplify powers of I, and then we're going to combine like terms. And I would do them in that order. Okay, so here is what I mean by this. We know that I squared is equal to -1. So this is really 16 plus 12i minus 8i minus 6 times -1. Well, what is a -6 times -1? That just becomes a +6, right? And then this 6 and this 16 are like terms. We add those together and we get a 22. And then these two are also like terms. 12i minus 8i is 4i. And that's the answer to that problem in the form a plus bi. Okay, so there's going to be some examples like that. And then we have to talk about dividing imaginary and complex numbers. And to do this, I want you to split your page into 2 parts. And first, we're going to remember how we dealt with radicals, because these are handled just like radicals. Okay, so we're going to do those first. So this is kind of a remember. What if you are dividing by 1 term or dividing by 2 terms? So here's what that looked like when we did radicals. We had something like 3 over rad 7. Do you remember what we did with that? Because you couldn't have a radical in your denominator, right? How did we deal with that to get rid of that radical? Well, if you recall, we took and multiplied by a whole new fraction that equaled 1, and that fraction was the denominator over itself. And when we multiplied here, we would just get 3 rad 7. Well, what's rad 7 times rad 7? That's just a 7. And if this is non-reducible, that's the answer to that. Okay? Well, when we do imaginary numbers, if we have something like, so here's the new example. we have something like 4 over 3i. Again, we're dividing by one term. Well, you're going to do essentially the same thing. You're going to multiply this whole thing by I over I. Because just like a radical, you can't have a radical in the denominator. Here, you can't have an I in the denominator. And we know that if we multiply by an I, multiply one I by another, we get an I squared. Well, what does I squared equal? Well, that equals -1. So this is really 4i over 3 times -1, which is, I'm going to go to the next line, 4i over -3. And we know we can't leave this negative in the denominator, so this becomes -4i over 3 or -4i over 3. Either one of these would be an acceptable way to write your answer, okay? But again, you're going to multiply by I over I. That's the strategy. And you cannot have an I in the denominator of your answer. And that holds true for both of these situations where we're dividing by either one term or two terms. Okay, so that's how you're going to deal with one term. Now, dividing by two terms, let's go back to the idea of the radical. So here maybe you had 3 over rad 7 minus 2. I don't know if you recall, but we did what's called multiplying by the conjugate. And if you need to remember, I'm looking back in my notes. Let's see. Simplifying square roots, multiplying radicals, dividing radicals happened in video number 33 or section 6.5, where we talked about and defined the, no, we didn't. Nope, it's 6.6, where we defined the conjugate and actually showed what that was. So I'm not going to reteach that. I just remember, or think that you should remember, or go back and consult your notes. So what we're going to do here to simplify this thing is multiply by rad 7 plus 2 over rad 7 plus 2. And then recall that we just distributed to the top and FOILed out the bottom. So if I FOIL out the bottom here, I'm going to get rad 7 times rad 7 is just plain 7, minus 2 rad 7 plus 2 rad 7 minus 4. These cancel out, and 7 minus 4 is 3. So that's my denominator. And then in the top, I get 3 rad 7 plus 6 over 3. Now here, I can actually simplify this, right? Because this 3 will cancel into this 3, and this 3 will cancel into this 6. So I can reduce this entire thing by 3. Canceling, canceling, canceling. And I now get 1 radical 7 plus 2. And that's the answer to that division problem, because we multiplied by the conjugate. That is the key here. Okay, so we're going to do exactly the same thing if you're dividing a complex number. So let's block off that, and this is going to be dividing a complex number by, dividing by a complex number. And so a complex number is a plus bi, right? So maybe we have, the problem is 4 over 3 plus 5i. We're going to, again, multiply by the conjugate, which is 3 minus 5i. Put anything with 2 or more terms in parentheses, and we'll distribute. And on the bottom, let's just go ahead and multiply underneath. I'm going to get 3 times 3 is 9, minus 15i, plus 15i, minus 25i squared. Well, these two things cancel. And then just writing all these steps down, 9 minus 25 times -1, right? I squared is -1. And so negative 25 times -1 is a positive 25. So 9 plus 25 equals 34. And that's going to be my denominator in my complex number. My numerator, I'm just going to distribute. So I get 12 minus 20i. And because these are all multiples of 2, I can divide out a 2. So this will become a 6, a 10, and a 17. And so this becomes 6 minus 10i over 17. Okay, so when you divide by single terms, you multiply by I over I. When you divide by two terms, you multiply by the conjugate. So those are the two different strategies that you're going to use based on the type of problem that you have. Okay, well, that's it. That's all the content. We'll have a chapter test and some review, obviously. This is 6.8, imaginary and complex numbers. Good job, everybody. Toodaloo.